Now, we all know Neutrik and their plugs, all our gear's held together with it, and they're fabulous people. It's always nice to see people moving into a new field. I'm not entirely sure they've got the hang of the radio mic thing. I'm going to ask Johan Winter if he can make a smaller one. Johan, I've known about Neutrik forever. They make the plugs that stick everything that I've got together. Well, this isn't the plug, what are you doing with this?
This is basically our wireless connector. Think of it as a cable, but then without the cable. You can connect wireless for audio, that is.
And what do you see this being used for? Just describe, okay, so technically, what have you actually built? How is this thing working?
So what we're trying to achieve here is making a connection, wireless, which is as solid and has the quality of a copper cable, basically. Think of it as a cable replacement. There where you cannot use a cable, you can use this.
Okay, and what are the specifications on it? So how are you transmitting? What sort of frequency band in here? Do I have to get a license? Or?
Yeah, this device works on 5 gigahertz Wi-Fi channels, but it is not Wi-Fi. It is our own protocol, and it sends continuous bits of data between A and B, the transmitter and the repeater, and it is not Wi-Fi. So another router or another wireless system cannot jump into our channel because it will see an occupied channel, basically, and that ensures us of a problem-free transmission without any delays. Obviously, it has its latency, but that's fixed. It has a fixed latency of 3.1 milliseconds. So that's acceptable, I suppose.
So I can see the basic case there, but I can see some variations you've got here. So what are you actually transmitting? Is this analog audio or data or what?
Yeah. So what we look at here is basically the base unit, and it's modular. That means in the top section there's the RF section, that's the actual transmitter. It transmits digital signal. And in the bottom section we can insert modules. And the modules we currently have is a dual line input, analog, or AES input, that's 2 digital channels basically, or 2 Danta channels, 2 audio Danta channels.
So you have this fourth option, which is the repeater, and what's the repeater about?
The repeater is about offering you a second path for the HF signal to travel, basically. If one path gets blocked by a high structure or something that moves, the system automatically chooses the path which is still free.
So okay, so I get that, Johan, but so why am I not just using one of my radio mics?
Yeah,
you know,
sure.
A pretty good analog radio mic, and now the new digital ones.
Yeah.
Why am I going to the trouble of using this system?
Well, typically a radio mic is what you say it is. It is a radio mic. It's not a cable replacement. A radio mic has limited frequency response. A radio mic has dynamics going on. That's what we'd like to avoid. You don't see that in a cable, so we don't offer it in our wireless product.
And okay, so what applications can you see for this system? Where can you see people using it? What would you be suggesting?
Well, being it is wireless, you're looking for places where you cannot use a cable. Of course, when you can use a cable, use a cable. But there are simply places where you cannot. When you need to cross water, when you need to cross a road, which is heavily being used. Like here on the fair, when you want to connect 2 islands, basically. But in the middle, there's a emergency escape or whatever path, whatever you call that. So there are simply places where you cannot run a cable. For instance, you could use this to make a connection to your delay system wirelessly. So you don't have to run a cable anymore. Power your delay system with a generator locally and connect this for the audio.
So you're that confident in it that you'd say that we could have a PA system absolutely live, and this is as good as a piece of cable to feed those delay towers?
Correct, that's how it is. Especially with the built-in possibility of the repeater, we can ensure a pretty stable connection, yes.
You're up in 5 gigs, so what is it about the 5 gig band that you've chosen now? Why not UHF or?
Yeah, well, there are basically 2 reasons for that. UHF, that's a crowded band, basically. Everybody is working in the UHF band. It's crowded. There's less and less space due to the television people and the telecom people, basically.
Fair enough, and but I mean 5 gigs, very crowded, isn't it? That's all Wi-Fi.
And the second reason is that you simply cannot get the bandwidth in UHF. So if you go digital, you need to have 2020K with 105 dB dynamic range. Then you need to go higher in frequency just to get the space for the transmission, basically. Then you look at, for instance, the 2.4 gigahertz, but that's crowded, overcrowded. So we jumped into the 5 gigahertz band, but then the higher channels, over 140. And that gives us the space, both channel-wise, but also bandwidth-wise. It solves 2 in 1, basically.
Okay, without asking you to give me an absolute, because no radio micro manufacturer will ever answer this question when I ask it. Very, very, very broad figures. What sort of range would you see it being used over?
Well, typically with line of sight of the antennas, you will reach 400 or 500 meters. But I also ran a test in a traffic tunnel, and that gave me 2.3 kilometers.
Whoa.
But that's a tunnel and that's a special environment, basically. But everything between that, I suppose.
That's fantastic, Johan. Thank you very much. So there you go, folks. Neumann are still making connectors. They're just making some connectors that don't even have a cable.
Yeah. So now we have copper, we have glass, and we have wireless. We connect the world.
So Jan, obviously, like every modern system, it has an app.
Yeah.
Can we have a quick look at what the features are there?
Sure. When initially starting up the app for the first time, it will ask you in which region are you. It shows you, in this case, the Americas, or Canada, or Europe. And by selecting that, you also select the properties of the device, as in how much power am I allowed to use on my antenna, basically, to stay within the regulations locally.
Just out of interest, what are the Americans allowed to run then?
Yeah, depending on the channel you choose, they will have power up to 4 watts. And in Europe, you have to live with 24 milliwatts. But power isn't everything, I can tell you. You can also overpower the signal, and that's also a big problem. But that's why we have the app, so that you can exactly see what's going on, basically.
Fantastic. And then once you've selected your area?
Yeah, we are in Europe today, obviously. So let's select Europe. It asks me, am I sure? And then it works. Let's go. Then it shows you some sort of manual. I don't know, for the purpose of this video, it's perhaps not a good thing to go through the manual, but let's skip this. And then it starts scanning for the devices you have on your site, and it takes them all in, basically. If you have 3 devices, then it finds 3. If you have 10 devices, it finds 10 devices. In this example, I found a transmitter and a repeater and a receiver and another receiver and another receiver. They are currently not connected. But when I drag those to the transmitter, it automatically connects. It asks me, or it tells me which antenna to use to stay within the regulations, basically. Now we're connected. And I can just drag another receiver to the transmitter, and it's connected, basically. And now, from this screen, I can tap, for instance, on my transmitter, and it shows me all the properties of my transmitter. Battery status, which modules are inside, is it a Danta or a AES or a line. It shows me the power of my batteries, as it will run something over 10 hours on batteries alone, but you can also power it over mains. And when looking, for instance, at a receiver, you will see that it also it shows you the quality of the signal from the original transmitter, the green bar, the top green bar, and the bottom green bar shows you the quality of the signal of the repeater. And then the receiver chooses between those two, which is best, and that will be sent out to the output basically.
So that really is true diversity, isn't it? In fact,
It is really true diversity, yes. Yeah.
Fantastic.